Question number 8, CY 2021. And the question is, reaction of AlIH4 with one equivalent of Me3N dot HCl gives a tetrahedral compound which reacts further with another equivalent of Me3N dot HCl to give a compound N. Now we have to find out the compound N, that is the chemical formula of compound N and its geometry. There are four options are given. Option A, the compound N is AlIH4 NMe3 and the structure of the compound will be trigonal bipyramidal. Then option B, Li2LH4Cl and the structure will be square pyramidal. Option C, the compound N will be AlH3 NMe3 whole twice and the structure will be trigonal bipyramidal. And option D, AlH3 NMe3 whole twice, the structure is pentagonal. We have to find out the correct answer among these four options. Now coming to the answer, we know that AlH3 is a Lewis acid. Since there are 3 valence electrons of aluminium and 3 electrons are coming from hydrogen, so the total valence electron in AlH3 is 6, 2 less than 8. Thus octet is not filled. Thus we can say that it is the aluminium center of the AlH3 electron is electron deficient. Thus it can act as a Lewis acid, that is attracting an electron field system. Now we can look into the formation of AlIH4. Lithium hydride will react with AlH3 to form AlIH4. We can represent the AlIH4 as Li5, Li plus and AlH4 minus. Now we all know that hydride is a Lewis base, thus is one kind of adduct of H minus and AlH3. The structure of AlH3 will be the ALH bond is weak in nature. It will liberate hydrogen. Thus, it is usually reacted as reducing agent. Since we know that AlH4 minus is one kind of adduct of H minus NH3, H minus and AlH3, thus some of the properties, that is the chemical properties of AlH3 also remain in the AlH4 minus. To keep AlH3 in normal room temperature condition open system is very difficult. They will form a dimer, thus making it less reactive. Thus, to use its reducing property, most of the time we use AlIH4 in place of AlH3. Now, the other compound given in the reaction, that is NMe3.HCl. Here, the NMe3 has a lone pair electron. Thus, it is a Lewis base. Now, we can think about a reaction between AlIH4 and NMe3.HCl as a reaction between a Lewis base and Lewis acid. The reaction will be hydrogen will be liberated. The structure of the first compound is given in the question, that is tetrahedral. Now it will react with another equivalent of NMe3.HCl to form the final compound, that is a compound N, and that will be AlH3 NMe3 whole twice. So this is our compound N. Now if we look into the options, there are two options which have the compound N represented as AlH3 NMe3 whole twice, that is option C and option D. So our answer will be between C and D. So we can cancel out option A and option B. Now we have to find out the structure of the compound N. First, to determine the structure, we have to start from electron configuration and then subsequent hybridization of the aluminum moiety, since it is the electropositive part in the molecule. So the first compound is AlH3 NMe3. So aluminum configuration is 3s 3p 3d. Configuration is 3s to 3p 1. After rearrangement, the configuration, electron configuration will look like now. NMe3 having its lone pair electron, it acts as a 2 electron donor in pair, that is they will donate a pair of electron, and hydrogen is 1 electron donor. Thus we can put the incoming electron from the electronegative hydrogen and NMe3 in the configuration of aluminum here, in the rearranged configuration of aluminum. These two are coming from NMe3 and these are coming from hydrogen. All these are sigma bond. For structure determination, we have to think about the orbitals are contributing in the sigma bond formation. So there are 4 sigma bonds, and which are the orbitals are contributing here? S and 3p orbital. So the hybridization is sp3. That is tetrahedral geometry, and the compound will look like now. We have to think about the second molecule, that is AlH3 NMe3 whole twice. Again, we can start from the rearranged configuration of aluminum, that is this one. This is the hypothetical rearranged configuration where S has 1, P has 2 and 3D no electron. Now since NMe3 will donate in pair, so they will go to completely empty orbital, that is one pair will go to one p orbital, and another pair will go to one d orbital. And the electrons from hydrogens are coming in the other orbitals, having one electron from aluminum. So these are a sigma bond formation. Thus the hybridization is sp3d. And the geometry corresponding to sp3d is tetragonal bipyramidal. The structure will look like, okay, these are axial and these are equatorial. So axial will keep the NMe3 to minimize the repulsion in space of the methyl moieties, and hydrogen in the equatorial position. Okay, the green portion is the trigonal planar system and the blue portion is the pyramidal system. So all total the system is tetragonal bipyramidal. Now the final answer. There we already cancel out A and B. Now in between C and D, which have the TBP arrangement? It's a TBP geometry, that is option C. So your answer is option C. For further discussion and understanding, you can keep an eye on lecture on main group elements hydride by Professor M.S. Balakrishna, Department of Chemistry, IIT Bombay. These are the YouTube videos corresponding to this metal hydride, group 13 hydrides. Thank you very much.